In this video, we're going to look at integration by parts. Now, integration by parts is a special way that you can method for integrating when you have a certain thing, and it is when you have, we look down here, you've got a product, so you've got u times dv by dx. So it's for special products, not all of them, but certain products then can be integrated using integration by parts. The formula for it is the integral of u dv by dx, where v is some function of x and u is some function of x, is equal to uv minus the integral of v du by dx. So it's a strange thing because you integrate, you start with an integral and you end up with, this bit has already been integrated, but you do end up with another integral. But the idea is that this integral here is a simpler integral than the one that you begun with, the one that you started with. Where this comes from then, we know our product rule, which is d, if you differentiate uv with respect to x, so d of uv with respect to x, you get u dv by dx plus v du by dx. Now, if we integrate everything with respect to x, if you integrate this with respect to x, you're going to get uv, and if you integrate this with respect to x, you're going to get the integral of u dv by dx integrated with respect to x, and integrate this with respect to x, you're going to get the integral of v du by dx integrated with respect to x. So just making this bit the subject, you arrive at the formula, which is the integral of u dv by dx integrated with respect to x is uv minus v du by dx integrated with respect to x. Okay, we're going to look at how we do this. And generally, to do this, you choose your u so that it simplifies on the differentiation. So you choose your u such that the du by dx term is a simpler term, an easier term to integrate. And you choose dv by dx so that it can be integrated. We're going to look at a couple of examples, and there'll be a special example which will appear here, which they're very fond of in examinations. Okay, the first example, you've definitely got a product. So you've got your x and your sine x. I'm going to pick my u to be equal to x, and the reason for that is my du by dx is going to be much simpler. It's going to be equal to 1. So if my u is equal to x, that just leaves my dv by dx to be equal to sine x. And v, how you get to v if you're at dv by dx, how you get to v is you integrate with respect to x. So the integral of sine with respect to x is minus cos. Okay, right, because we're just new to this, we're going to write down the formula every time. So u dv by dx integrated with respect to x is equal to uv minus the integral of v du by dx integrated with respect to x. So here, in our case, our u, we have said it was x, and our v was minus cos x. So uv is going to be minus x cos x, then minus, and my v was minus cos x, and my du by dx was 1. So we don't need to write it in, we can just write it like that. Okay, we'll just tidy up before we integrate. We'll tidy up with a minus and a minus together, so I can just change that to be plus the integral of cos x dx, and then we'll go on. That's minus x cos x. That bit's already been integrated, remember, and if you integrate cos, you get sine. And remember your constant of integration, and that's it. So what we have got, we find if we integrate x sine x, you get minus x cos x plus sine x plus c, and that's it. Okay, example 2, same idea here. I'm going to let my u be equal to x. That means my du by dx is equal to just 1. My dv by dx is equal to e to the x. So we've looked at our e to the x, integrating it a couple of times. So if you integrate e to the x with respect to x, you just get e to the x. So I'm going to say, okay, so we go on and we can just say our integral is equal to uv minus the integral of v du by dx. So just fill in what you know. Your u was x, your v was e to the x, so it's x e to the x minus the integral, and again it's e to the x just because your du by dx was 1, and then you go on and integrate, you'll get x e to the x minus e to the x integrated is just e to the x, and then plus your constant of integration c. Okay, the last example is a very special example, and as it says here, it's a favorite of the examiners. So what we're going to do in this one, and it's the same idea had it been x ln x or x squared ln x, you would do the same method as I'm about to show you. So we're going to rewrite first of all, and we're going to think about it as being 1 times ln x dx. Now, normally we would let the u, and this is what's strange here, normally we would let u be the thing such that du by dx is a very simple function. But here we're going to let your u be equal to ln x. That means your du by dx is equal to 1 over x. That means your dv is only left that it can be 1, so your v is equal to x. So your integral, I, is uv minus the integral of v du by dx, and then we can get cracking with it. So your ln x times your u times your v is going to be ln x times x, or just write that as x ln x to avoid any confusion. Then minus the integral, my v is x, my dv, what du by dx, is 1 over x, and then we can go on with this. So that's going to be x ln x minus x times 1 over x is just going to be 1. So that's 1 integrated with respect to x. And if you do your final integration, you're going to get minus x and then plus your constant of integration, c. And that is it. Okay, so this is not in your notes, but say the question had been x ln x, your u would again be equal to ln x, your dv by dx would be equal to x, meaning your v would be equal to x squared over 2, and your du by dx would be equal to 1 over x. And you can see then the hard bit, the integral part, would be v du by dx, so it's going to be x squared over 2 times 1 over x, so it just becomes x over 2, which you can integrate, which is the whole point of this. Okay, folks, I will delete this from the notes, and then questions you can do. Topic 7, integration B, exercise 6, just do questions 1 and 2. The next video will be on definite integrations of using integration by parts, so just wait until you can see you watch that video.